Traditional AI is a $200 billion a year market. It's used in marketing, supply chain, and a number of other applications. However, 70% of traditional AI projects fail to deliver an ROI. In this demo, we will show how BizML can improve feature engineering and feature selection to boost signal to noise ratio, significantly increasing accuracy and reducing error rates. This portion of the video showcases BizML's ability to significantly improve predictive analytics. The specific example classifies valid LLM responses versus hallucinations. I start by loading the hallucinations CSV file, which has prompt and three responses, showing analyzing multiple responses for a prompt is a valid hallucination detection and management strategy. It then has four columns that are derived from that information. First one is prompt to response similarity, blue score, bird score, and a response to response similarity. The last column consolidated identifies whether it's a hallucination uh, uh, and or refusal versus valid response. As a next step, I limit the columns to what I do need to do the analytics. So it's got the four scores, the inputs, and the output label, which is the consolidated column. Next, I use PyCarry classification and I set it up. Uh, and as you can see, it's got 68 records, four numeric features that are used as input, and the consolidated column that is used as the target label. Next, I ask PyCarry to compare multiple models. These multiple models are trained, and the best ones are selected and ranked higher. The results are in. You can see the accuracy is 79%, which is pretty high. However, the data set is imbalanced, which is why you have a relatively low F1 score, kappa score, etc. Um, and um, and so and also looking at this, you can almost assume that 76.5% of the data is non-hallucination, which is why F1 and kappa score are zero for this particular data set. And so now I want to boost the signals that you get from the data by doing feature engineering. So I'll import the BizML uh, library and take the raw data and create feature engineered data. And now you can see that you have four new columns that each of those columns have been feature engineered, and the output is still the consolidated column. And now I set up PyCarry to do training, and you can see that it's still four features, but this time it's feature engineered features that are going into the model, and the target is still the consolidated column. And then I ask PyCarry to compare, to train multiple models and to compare them. And as shown before, PyCarry starts executing and comparing these models. The results are in, and as you can see, the accuracy went up by a little bit. It went from 79% to 81%. However, for that particular case, F1 score and kappa are down. So if you want to focus more on statistical significance overall, then naive Bayes gives you the best results. And to some extent, it can be considered a small win because naive Bayes is a simpler model that's much more explainable. So, and this is partly occurring because when you do feature engineering using semantic brains algorithms, it can boost both signal and noise. So you might not just get the best results by doing feature engineering alone. Therefore, what I want to do is do feature engineering and feature selection. So I do feature selection and essentially it did the analysis and basically said that one column uh, that has the bird score is no longer is likely introducing noise. So it came up with different set of values, and I set it up to run with PyCarray, and now you can see that there are only three numeric features. We unselected or deselected one of the columns, and everything else is the same. Now I ask PyCarray to train and compare multiple models, and it starts executing. So the results are in, and as you can see, the accuracy, the best model had an accuracy of 87%. That's a significant improvement. It went from 79% to 87%. That's approximately a 10% lift on accuracy. And if you look at it from an error rate perspective, it had a 21% error, and now it has a 13% error rate, which is a 38% reduction in error rate, which is quite significant. And the statistical significance has also increased, like the F1 score and the kappa score clearly reflect that this model is much better, the result of which is most hallucinations are being detected now. Um, BizML is not limited to classification and predictive analytics. It can be used to build regression and time series models and build diagnostic and prescriptive analytics solutions. AutoML, in conjunction with BizML, significantly increases accessibility, enabling business users, data analysts, and software engineers to develop powerful solutions. Data availability is less likely to be a showstopper, and organizations can make many cost benefit trade offs.